Hello all. In this video session we will be discussing about rewind function, ftell function and fseek function. All these functions are defined in the header file studio.h, and in this rewind and fseek deals with moving the file pointer to a specific location, and ftell deals with finding out the location or the current location of the file pointer. Okay, we will see all of these functions one by one. First one is rewind function. So rewind function sets the file position to the beginning of the file. Okay, so this is the syntax for using the rewind function. Rewind, then inside parentheses we should provide the file pointer. So what it does is that after executing this rewind function, the file pointer will be pointing to the beginning of the file. Okay. Now the next one is ftell function. Now this ftell function is used to find out the position of file pointer in the file with respect to starting of the file. Okay. So ftell of fp means it will return the position of the file pointer with respect to the starting of the file. That means that when we execute this particular statement, it actually returns a long value, and if it is pointing to the beginning of the file, then it will give 0. Okay, and if it is pointing to the fifth byte in the file, then it will return 4. Okay, so with respect to the starting of the file, it will return the position of the file pointer. Okay, anyway, we will see in detail how ftell works. Then after that we have fseek. So fseek is used to move file pointer associated with a given file to a specific position. So if we want the file pointer to move to a specific location, we will be using this fseek function. And fseek function has 3 arguments. First one is the file pointer, second one is the offset, and third one is the whence. That means from a particular location. Okay, so fseek fp offset comma whence, where the whence is should be our reference place. Okay, so there are macros defined for this reference points. So we have seek underscore set, which is actually a macro, and the value of seek underscore set is 0, which means beginning of the file. Then there is seek underscore cur, which means the current position of the file pointer, or you can give 1 as well. Okay, so this macro seek underscore cur is having the value 1, so you can use 1 as well. Then next one is seek underscore end, which means the last position of the file. Okay, so the seek end is again a macro, you can replace it with 2. Okay, so macro expansion of seek underscore end is 2, so you can use 2 instead of seek underscore end as well. Okay, so these are all reference points: seek underscore set, beginning of the file; seek underscore cur, current position of the file; seek underscore end, the last position of the file. Okay, so this is the reference point, and the offset means from that reference point how many bytes. Okay, so if I give 2 and then I give seek underscore set, that means that from the beginning of the file it should move 2 bytes. Okay, so offset is how many positions you want to move with respect to this relative position. Okay, so that is the syntax for fseek. Now we will see working of all these functions, but first of all just refresh the program that we done for printing the contents of the file. Okay, so this is the same program. Using getC function we are printing the content of the file, that is cdemo.txt. Okay, now if you observe here, we are just reading character by character and printing that particular value. Okay, so I'm just going to run this program. So gcc fseek demo.c output it to fseek demo.out. Okay, compiled it, no errors. Then I'm going to run this /fseek demo.out. So the content of the file is hello, how are you, then a smiley face. So these are the content of the file. Okay, now first of all we will be seeing the rewind function. So you know that this is the loop using which we will be getting all the characters from the file and then we will be printing it, right? Okay, if you don't know about fgetC function, so just go and watch the video on fgetC function and fputC function, and then come back here. This is the same program that I used there. Okay, so now after reading all the characters, this fp will be pointing to the end of file, right? So once it exits from this fp will be pointing to end of file. So if I try to print it one more time, okay, so I'm just going to trying to print it one more time. Our file pointer is in the last position, right? Printing one more time. Okay, so since the file pointer is at the last of the position and we want to print it from the beginning of the file, I will just rewind that file point. Okay, so if I rewind that file pointer, what happens is that it will move the file pointer to the beginning of the file, and it will again print this content of the file one more time. Okay, now if I haven't given this rewind, then it will only print that particular content only one time. Okay, so because after printing this hello how are you, it will be pointing to end of file. So in this line of code this statement won't be executed since fp has already reached end of file after executing these statements. Okay, so in order to again read from the beginning of the file, we should give rewind of fp. Okay, so if I give that, then it will work and this will be printed one more time. So this is the use of rewind. It will move the file pointer to the beginning of the file. Okay, so that is the use of rewind. So I'm just going to comment this statement. Okay, then I'm just going to modify the way this code is written so that I can show you the value of ftell of fp and its corresponding value in the file. So I'm just going to make that modification. So I'm just going to read, I'm just going to cut this. So what I do is that I'm just going to read that character, and then if that character equal to end of file, then I'm going to break from there. Okay, so if it is end of file, then break from there. Okay, so I'm just going to give an infinite loop here. So when it reaches end of file, it will exit from here. Okay, I'm just going to check whether this code will work. Okay, it will work. And after that, what I'm going to do is that here we are printing the character. So before printing the character, I'm just going to print the file pointer as well. Okay, so initially I am printing the file pointer. So I'm going to print the file pointer. Okay, so since it is returning a long value, I'm just going to give %ld. Then after that, I'm going to give ftell of fp, which is actually a function which tells us the position of the file pointer with reference to the starting position of the file. Okay, so now the reason why I have given statement above this fgetC statement is that because initially the file pointer will be pointing to the first position, that is okay, if I consider this example, it will be pointing. Okay, I'm just going to clear this, then I'm just going to print the content of cdemo.txt. Okay, so initially the file pointer will be pointing to h, right? And after that, when we call the function fgetC of fp, what happens is that this h is read and file pointer moves to here. Okay, so after this statement is executed, the file pointer advances to the next location. That's why I have given this ftell of fp before this fgetC of fp function is called, so that I can get the file pointer value at the beginning. At the same time, I can print that particular character. Okay, and I'm just going to save this. And now what this program does is that the first position will be 0. This is 0. After printing 0, the first character will be printed. Then FP will be automatically incremented when this statement is executed. So next, this ftell of FP will become 1. Okay. Now always remember that here this ftell of FP is incrementing by 1 since we have characters inside this file. Okay, so the size of character is 1 byte. So it will be incrementing by 1. Okay. It may not be the case when we are using integers or structures. Okay. Okay, I'm just going to compile this. Then no errors. I'm just going to run this. Okay. Okay, I have just made a mistake here. You have to put 2 spaces, otherwise all of them will be grouped together. Okay, so I'm just going to clear this. Then compile this. Then run this. Okay. So at 0th position we have H, then 1E, then 2L, then 3L, 4O. Then the 5th position we have the Newland character. Then at 6th we have capital H, then O, how, space, R, U. Then we have the question mark. Then at the 18th position we have again Newland character. Then 19 colon. Then after 20 we have the hyphen. Then after 21 we have the close parenthesis. So now this ftell can be also used to find out the size of our file in bytes. So I'm just going to print that size of files in bytes. That is, after reaching the end of file, if I print out the value of ftell of fp, then it will be the size of file in bytes. Okay, so I'm just going to compile this and run this. And if you observe here, okay, I have to put a \n here so that it will be printed in new line. Okay, so compile, and then I'm just outputting it. Okay, now if you observe here, the size of the file in bytes is 23. Okay, so this was the content of our cdemo.txt, and we are having the value here HELLO, then Newland character, then how are you question of the Newland character, then colon hyphen close parenthesis, then a Newland character. So this will happen if we compile this program and run this program. So what it does is that it will print all these file pointer locations and then the corresponding character. So this is the first line, then from 5 we have the second line, then from here we have the third line, and from here you just terminate it. Okay, so at location 23 we have the end of file which will terminate our program. Okay, so this ftell can be used to find the size of bytes as we have seen here. So size of file in bytes is that I'm just going to give ftell of fp where fp is pointing to the last position or end of file in the file pointer. Okay, so that is 23 bytes. So 22 bytes for storing this information and 1 byte for storing the end of file. It's a use of ftell function. Okay, so we have seen rewind and ftell function. Okay, now we will see the fseek function. Okay, so this is not required, so I'm just going to comment this statement. Okay, so that it will be printed in a normal way. Okay, so now if I compile this, okay, this is our normal output, and then the size of file is also printed. Okay, now here fseek moves the file pointer to a specific location related to this relative position. Okay, so we have 3 relative positions: seek underscore set, seek underscore cur, and seek underscore end. So we are going to experiment with these values. So I'm just going to put fseek instead of rewind. Okay, so fseek of, initially I'll be giving the first parameter is file pointer, then with respect to the relative position, that is if I am going to give seek set how many position I should move. The offset from seek set or beginning to the file, I'm going to give 0. That means seek the file pointer or move the file pointer to the beginning of the file. Seek underscore set means beginning of the file, and from beginning of the file move 0 positions. Okay, so this fseek will be pointing the cursor to the beginning of the file. Okay, so I'm just going to compile this, clear, then sorry, compile, then run. Okay, so using that I have printed the file one more time. So this fseek statement is same as using the rewind function. Okay, consider that I want to print something after 6 characters. Okay, so you know that the file pointer will be starting from 0, 1, then 2, then 3, then 4, and then 5 is our new line character, and this is our 6th character. Okay, if I am starting from 0th location, this will be the 6th location, and to print from here I can give, instead of that fp, I can give 6 here. Okay, so here after, okay, I'm just going to change this printf statement. So okay, I'm going to give this after this. Okay, so after this what will happen if I clear this, then compile, run. Okay, so after fseek fp of 6 underscore seek set is performed, it will be only printing from how are you till end of file, because we are given the loop to print till the end of file is reached. So it will be starting from position 6 and then printing it till end of file. Okay, now if I give something like 19 here, okay, so I'm just going to give 19 here. So here if you count 0, 1, 2, 3, 4, 5 new line character, 6, 7, 8, 9, 10, 11, 12, 13, then 14, then 15, then 16, then 17, and then 18 is our new line character. So it will come to the 19th position, we will get the smiley face. So I have given the position 19 here. Okay, from the beginning move 19 positions. Okay, so here we have to mention the size in bytes. So 19 bytes I have mentioned. So now if I compile this program and run this program, you will be getting the smiley face. So this is how you can use the fseek. And okay, I'll just comment this. There is one more way of using this fseek. So we'll just demonstrate that. So after fseek of, instead of giving the reference point at the beginning, I'm just going to give us at the end. Okay, so from the end or before the end, I want to read, let's say, last 4 characters or 5 characters. Okay, in that case I will be giving this. Okay, so it will read 4 bytes before the end of the file. Okay, so that is the use of this negative value. So I'm just going to change here. Okay, just going to save this, clear this, then compile this, and okay, just going to run this. Okay, so if you observe here, after fseek fp of -4, again we are getting the smiley characters. That are the last 4 characters. If I want to get the last 2 characters, then I can give -2, then it will be printing the what? Okay, sorry, I have changed only the printf statement. I have not changed the value 2 here. Okay, so that's why it printed in wrong way. Okay, now I'm just going to compile this and run this, and it will be only printing the last 2 characters, that is the close parenthesis and the new line character. Okay, so these are the ways you can use this fseek function. So we can use the reference points or reference positions or vens as seek underscore set, seek underscore cur, seek underscore end, and all of these have macro definitions. For example, seek underscore end is having the value 2, so you can use this as well. Okay, so if I use this, then also it will work. Okay, so both are acceptable. Okay, anyway, for easiness, it is better if we use the macro. Okay, so this is how we use fseek function. Okay, so these are the functions that we learned today. We learned rewind, then we learned ftell, and we learned fseek. And remember the arguments inside each of the function, and also remember the use of this fseek function. Okay, so this rewind is useful when we again want to read the file from the beginning of the position. Then fseek is very useful when we want to do some random access. Since fseek moves the file pointer to the specified location, we can easily access from that particular location. Okay, so remember about fseek, the arguments, that is this vens, which is the relative position. Seek set means seek set of 0 means beginning of the file. Seek underscore cur or 1 means the current position of the file pointer. Seek underscore end means the last position of the file, or you can also give 2 as well. Okay, since that is a micro definition of seek int. Okay, so this is how all these functions works. Okay, just remember about that. Okay then, thank you.